Hello and good morning, everybody. Welcome to another edition of Breakfast by the Bay. My name is Jeff, and I'm joined by Miss Megan behind the cameras here. And we are coming to you live from our Exploration Center and Aquarium right here in Newport, Rhode Island. So we want to thank 11th Hour Racing for sponsoring Season 2 of our Breakfast by the Bay series. And we want to thank our fans and family and friends and students that are all tuned in for Breakfast by the Bay. We really appreciate you guys watching our videos, and if you could like and subscribe to our YouTube channel, that would definitely be a huge benefit for us. And so as we go along with our lesson today, if you have any questions or comments or concerns, please feel free to use that live chat function. And yeah, so as we go along, I'll try to answer your questions, and then we're going to talk about horseshoe crabs today. So one of my favorite animals that lives in Narragansett Bay is the horseshoe crab. So I have a model of a horseshoe crab, a molt, and I have two live species of horseshoe crabs, or live organisms of them. And we're going to talk about some quick facts about them. So the first thing is, horseshoe crabs are an invertebrate. They do not have a backbone. And even though they're called a crab, they're actually not a true crab at all. They are in the arachnid family, which means they are closely related to spiders and scorpions and ticks. So they're not a true crab at all. They've also been living on Earth for about 360 million years. So over 360 million years. They're older than some of the dinosaurs, and they're still around today. So they've been able to survive some mass extinction events, and they look pretty much exactly the same as they did 300 million years ago, which is pretty crazy. We're going to talk about their anatomy, but it's good to know that they have a segmented body. So you can see they have the top part, their head, their middle part, their abdomen, and their tail down here. And they have jointed legs. So we're going to look at their legs up close in a minute. But their legs are jointed, which means they can bend them. Just like we have our elbow to bend our arms, our wrist to bend our hands, they have jointed parts of their legs. And they also have an exoskeleton, which means the skeleton of their body is on the outside. So they have this hard skeleton or exoskeleton outside their body. And it's unique because as they grow, they can only get as big as their exoskeleton, right? So what I'm holding here is something called a molt. And a molt is their old exoskeleton that they outgrew. So if you look up close here, there's this little seam where it's split. That molt is cracked open. Those horseshoe crabs were actually able to crawl out of their old exoskeleton, grow a little bit bigger, and then harden up their new exoskeleton that's larger for them. And they leave behind their old molt. A lot of people will find these molts on the beach, washed ashore, and they think it's a dead horseshoe crab. But this horseshoe crab is still alive. We have him living in our aquarium right now. He just outgrew his old exoskeleton and left this one behind. Alright, and a last quick fun fact about horseshoe crabs is that they are in a class of their own. They are in the class called Merostomata, which translates to meaning legs attached to mouth. So if we look at our horseshoe crab molt, they have all of these legs, and then right in the middle of those legs, they have their mouth here. Awesome. So I'm going to put the molt down because it's a little bit fragile, but I'm going to pick up our model. So this is not a live horseshoe crab. This is a plastic model that we use to study the anatomy or body of our horseshoe crab. Alright, so we said horseshoe crabs have a segmented body. This top part of their body here is their head, also known as their helmet. And this is where they get the horseshoe name. You can see it looks like a half of a circle, or a horseshoe shape. It is also a dark brown color, kind of greenish. That helps to blend in and camouflage with their habitat. So these guys crawl around the bottom of the bay through the sand and mud, and they have to blend in with that sand and mud. And that hard exoskeleton acts as a defense or armor from predators. If you look up close at their head, they actually have these two compound eyes. So they have eyes they can see, but their compound eyes are pretty unique. It's kind of like looking through a kaleidoscope. So if you've ever looked through a kaleidoscope, you see one image that's refracted into 100 smaller images. That is how these guys are seeing the world. But they have 10 eyes total. So they have 2 compound eyes, and they actually have 8 light-sensing eyes. Along the rim of their helmet and down their tail, They have light sensing eyes, which can just see the shadows of lightness and darkness. Alright, so if I flip our horseshoe crab model over, we can check out underneath the helmet here. They actually have 10 legs, so that's easy to remember, 10 eyes and 10 legs. Their legs are jointed so they can move and bend them, and they're really good at crawling through the sand and mud and digging and burying themselves in the mud using their legs. And remember, their mouth is central to all those legs right here in the middle. So their mouth is very different from a human mouth. They don't have teeth, they don't have lips or a tongue. All they have is these hard bristles and palates. They kind of scavenge along the bay looking for any dead fish or food or shellfish, and they can kind of use their legs to scoop it up into their mouth here. Awesome. Alright, so that is their head or helmet segment of their body. The next part we're going to see is the abdomen, which is the middle section here. So this is their abdomen. Just like humans, we have our abdomen in the middle of our body. They have this hard exoskeleton on the outside to protect them. They also have some spikes here that act as another defense mechanism from predators. And when I flip their abdomen over, on the underside, you can actually see their gills. So they have what are known as book gills, and those book gills are what they need to breathe underwater. If we check out our molt, it's a little bit easier to see those book gills. So I'll try to hold it up close. They can actually look like pages of a book that are flapping through the water, and that is where they are taking oxygen from the water so that they can breathe. Pretty interesting. So the cool thing about a horseshoe crab is they've actually studied to live out of the water for up to 2 weeks. So these guys can crawl out onto the sand when they're breeding, and as long as that sand is wet and moist, they can use that wet, moist sand to stay alive by breathing up to 2 weeks out of the water. Alright, and the last part of the horseshoe crab that I want to show you guys is the tail, or the telson. So the tail here looks kind of menacing and scary, like it's a weapon, but it's not used as a weapon at all. So a lot of people get horseshoe crabs confused with stingrays because of their shape and their long tail. Stingrays have a stinger or a barb on their tail, whereas a horseshoe crab only uses its tail to flip itself up. So sometimes they get stuck upside down on their back. They don't like being this way because they're very vulnerable to predators. So what they can do, stick their tail in the ground and roll their body right side up. That's pretty much the main function of their tail. It's not any type of defense or weapon. It also helps them to steer while they're walking through the water as well. Alright, so those are pretty much all the important anatomy or body parts of our horseshoe crab. And in just a minute, we're going to meet two of our live species. We're going to see them up close, but first, I want to talk to you about horseshoe crab blood. So here's a picture of what that blood looks like. So they actually have blue blood. You can see all the horseshoe crabs that are lined up and those IV drips coming down. So that blue blood in those vials is being collected by scientists. So their blood is actually really important to the biomedical industry. They have a unique copper-based blue blood. So because there's copper in their blood, that's what gives it that bright blue color. And their blood contains a substance called limulus amoebocyte lysate, or LAL. And that blood is a vital resource to the medical field. Their blood has the ability to identify bacterial contamination. So if there's any type of contamination, their blood will identify and coagulate around it. And it's actually used a lot by the FDA in testing for vaccines. So right now we're all waiting for the coronavirus vaccine. The FDA does lots of tests to make sure that that vaccine is safe and healthy for humans. And one part of that process is actually using the vaccine on horseshoe crab blood to make sure that there's no bacterial contamination and to make sure that it's healthy and safe before we give it to humans. So we have to thank horseshoe crabs for their special blood for any vaccines we have to use. Very special. Alright, now for the last part, we're going to meet our live horseshoe crabs here. So I'm going to take out a towel. These guys are in the water. You can see them roaming around over here. Awesome. So the first horseshoe crab I'm taking out is a female. She's a little bit larger, so females can actually grow twice as large as a male horseshoe crab. But again, we know all of their body parts. They have their abdomen, and they have their telson, or tail. And when I flip her up, she's very threatened and vulnerable, so she's wiggling that tail around a lot to try to flip herself back over. But you can see all of her jointed legs. Remember, she has 10 legs. She's bending and twisting those legs around. And in the middle, she has her mouth. And then at the bottom of her abdomen, she has her gills, her book gills. So one reason I know this is a female is because she's larger than the male. But also, if you check out her front pair of walking legs, she has a peace sign. So her front pair of walking legs looks like two fingers making a V or a peace sign. And that is how I know it is a female. So let's take out our male, and we can compare those front pair of walking legs. Alright, here's our boy. He's a little bit smaller than the female. And if you look at that front pair of walking legs on him, it kind of looks like a boxing glove with its thumb sticking out here. So the males have a unique set of front pair of walking legs, and they use that to actually attach themselves to the females. So when it's time to breed, they use that hook to hold on to the backs of a female, and the females kind of give them a piggyback ride through the sand. Awesome. And he's also a bit smaller. Cool. Alright, so I'm going to put these guys back in the water. And that is all I have to tell you about horseshoe crabs today. So hopefully you enjoyed our video, and hopefully you guys will be back to join us next Wednesday at 10 a.m. for another edition of Breakfast by the Bay. Again, shout out to 11th Hour Racing for sponsoring us this season, and I'm wishing everybody a happy Thanksgiving. So awesome. See you guys next time.